The Pilgrim 1 spacecraft of NASA currently holds the record for the farthest distance traveled by any human-made object. It has fascinated people across the globe for nearly 50 years. Voyager 1 has communicated ever since its launch, transmitting vital data from the furthest parts of the universe and expanding human comprehension of space. However, the spacecraft's ongoing transmissions have recently confronted bizarre anomalies that have left scientists puzzled. These mysterious signals have ignited intense discussion, making the scientific community question whether these anomalies are simple malfunctions or signs of something much more extraordinary, possibly even extraterrestrial activity. Join us as we investigate these puzzling signals and explore what could lie hidden in the vastness of space. The human desire to discover the unknown has always been the driving force behind space exploration. The result of this deep-seated curiosity was the creation of ambitious objectives like Pioneer 1 and Explorer 2, which were among the most daring space missions of their time. On August 2, 1977, the launch of Explorer 2 from NASA's Kennedy Space Center marked the beginning of a new era in space exploration. Shortly afterward, on September 5, 1977, Explorer 1 was launched, setting off on a path that would eventually take it toward the outer planets, significantly modifying its orbit and the results of its mission. These two spacecraft, each weighing approximately 7,720 kilograms, about the size of a small car, traveled in separate directions at varying speeds. On December 15, 1977, a key milestone was achieved when Explorer 1 surpassed its twin in distance traveled, due to the different routes they followed. Since that time, Explorer 1 has proven to be an invaluable tool in broadening our understanding of the universe, offering insights that have transformed how we perceive space. Before we delve into some of its most recent groundbreaking findings, let's first review some of its earlier major achievements. In 1978, while situated around 265 million kilometers from Earth, Explorer 1 successfully captured detailed imagery of Jupiter. By January 1979, the spacecraft had completed an amazing 100-hour mission that produced a time-lapse video showcasing the rotation of Jupiter. This series of 3,750 images provided unprecedented views of Jupiter's chaotic atmosphere and intricate features. Additionally, the spacecraft discovered a previously unknown ring encircling Jupiter and two brand-new moons, significantly enhancing our understanding of the gas giant's complex system. To guarantee its safe travel and avoid potential collisions with Titan, one of Saturn's moons, the spacecraft performed a series of correction maneuvers. Following this, the focus of the mission shifted beyond the planets of our solar system as the spacecraft was redirected toward interstellar space, traveling at an astounding rate of 325 million kilometers per year. In January 1990, Explorer 1 embarked on its mission to explore interstellar space, continuing its journey beyond the solar system. During this phase, the spacecraft achieved several remarkable milestones, including the discovery of 4 additional moons, Mimas, Enceladus, Tessis, and Rhea, and capturing some of the most iconic images of our solar system's outer regions. On February 14, 1990, at a distance of about 6 billion kilometers from the Sun, Explorer 1 took its famous family portrait, capturing stunning photographs of the inner planets. This collection of 60 images joined the spacecraft's portfolio, which also included 670 images taken during its flyby of Neptune. Explorer 2, meanwhile, also attained impressive milestones. It recorded wind speeds on Neptune of over 13,100 meters per second, the fastest winds ever recorded in the solar system. It also provided scientists with essential data on Neptune's atmosphere and its moon Triton, which has surface temperatures plunging to a frigid -391 degrees Fahrenheit, making it one of the coldest places in the solar system. Triton also displayed ice volcanoes ejecting nitrogen gas and frozen particles up to 5 kilometers high, offering an exciting new perspective on the moon's features. These extraordinary discoveries have greatly expanded our understanding of the diverse and dynamic environments in the outer reaches of the solar system. The contributions of both Explorer 1 and Explorer 2 have exceeded all expectations. Their groundbreaking missions uncovered previously unknown details about the moons of Jupiter and Saturn, once thought to be dormant. These findings reshaped our understanding of the geologically active nature of these moons. In particular, Explorer 2 made history by becoming the first spacecraft to fly by both Uranus and Neptune, an achievement yet to be repeated. NASA employed a variety of innovative strategies to extend the missions of these pioneering spacecraft, such as shutting down non-essential systems to conserve power. The mission is expected to continue until 2030, marking the end of an era for the engineers and researchers who have dedicated themselves to this extraordinary journey. The designs of Explorer 1 and Explorer 2 showcased cutting-edge engineering. These spacecraft were built to rotate slowly, reducing blur in their images as they traveled through space. Even before reaching the outer planets, the spacecraft began transmitting detailed images of Jupiter, revealing its swirling clouds and iconic Great Red Spot, a massive storm that has intrigued scientists for decades. However, the most exciting discovery came with the identification of active volcanoes on Jupiter's moon Io. The spacecraft's instruments detected unusual signals from the moon, later confirmed by images showing towering volcanic plumes and a surface characterized by powerful eruptions. One of the volcanoes on Io erupted with 1,000 times the force of Mount St. Helens, covering an area nearly as large as France. As the spacecraft continued their journeys, they were eventually powered down to conserve energy before starting their voyage into the interstellar void. The extraordinary images they captured did not include Mercury or Mars due to technical limitations. NASA later launched additional noteworthy spacecraft, including Pioneer 10, Pioneer 11, and New Horizons. On February 17, 1998, Pioneer 10 surpassed Pioneer 11 to become the farthest spacecraft from Earth. Despite this, Explorer 1 continued its solitary journey for an additional 14 years before finally entering interstellar space on August 25, 2012. The success of these Explorer missions was largely due to the innovative utilization of gravity-assisted maneuvers, which helped propel the spacecraft to their destinations while conserving fuel. Instead of solely relying on their propulsion systems, the spacecraft utilized the gravitational pull of planets to increase their speed. This technique allowed them to cover vast distances without depleting their fuel supply. As Explorer 1 approached Jupiter, the planet's immense gravity accelerated the spacecraft. Precision was essential to avoid catastrophic deviations in trajectory or speed. These maneuvers allowed the spacecraft to navigate their journeys through the solar system and beyond. Similarly, Explorer 2 utilized gravity assists from Jupiter and Saturn to reach Uranus and Neptune, demonstrating the efficacy of this technique. The spacecraft's plasma wave detectors picked up subtle variations in the density of space, allowing scientists to map the boundaries of the heliosphere, the bubble-like region of space dominated by the solar wind. When Explorer 1 crossed this boundary in 2012, it officially entered interstellar space, providing the first direct data from beyond our solar system. This transition marked a monumental achievement in human space exploration. For the first time, a human-made object was no longer bound by the solar system, offering a new perspective on our place in the galaxy. Scientists detected a dramatic shift in particle density and magnetic field direction, confirming that the probe had entered a region influenced more by the Milky Way than by the Sun. In the years that followed, Explorer 1 continued to send back valuable data from the interstellar medium, a region filled with cosmic rays, dust, and plasma. These findings helped scientists refine models of how our solar system interacts with the galaxy and provided insights into the protective role of the heliosphere in shielding Earth from high-energy cosmic radiation. Meanwhile, engineers on Earth faced increasing challenges in maintaining contact with the distant probe. The signals from Explorer 1, now billions of kilometers away, took over 21 hours to reach Earth. Maintaining a steady link required precise calibration of antennas and continued innovation in deep space communication technology. Despite these challenges, the spacecraft has remained operational, outliving its original mission expectations by decades. Its continued functionality is a testament to the durability of its design and the ingenuity of the teams behind it. As the anomalies in recent transmissions continue to puzzle scientists, efforts have intensified to determine their origin. Could these irregular signals stem from hardware degradation after nearly 50 years in space? Or are they perhaps influenced by unknown cosmic phenomena? One theory gaining attention is that Explorer the First may be encountering previously undetected forms of interstellar matter, which could be interfering with its instruments. Another, more speculative theory suggests the signals may be artificial in nature, potentially evidence of contact with non-human intelligence. Although such a possibility is currently considered unlikely by most experts, the nature of the signals has not yet been conclusively explained. Their irregular frequency, structure, and persistence distinguish them from known malfunctions or background noise. NASA has assembled a dedicated task force to analyze the data in detail, involving experts in astrophysics, signal processing, and systems engineering. International agencies and independent observatories have also been invited to assist in the investigation, emphasizing the global significance of the findings. While we await more definitive answers, the story of Explorer 1, and its twin, Explorer 2, remains one of humanity's most extraordinary achievements. These missions have expanded the boundaries of our knowledge, bridged vast cosmic distances, and sparked curiosity across generations. In many ways, the journey of these spacecraft mirrors our own search for meaning in the universe, propelled by wonder, guided by science, and sustained by the hope that, one day, we may find that we are not alone. Interactions between these planets and their environments. The plasma wave detectors helped us understand the behavior of solar wind and its effects on planetary atmospheres. One of the most remarkable accomplishments of the Voyager missions was their ability to measure the heliosphere boundary, a region filled with solar particles and magnetic fields that surrounds our solar system. As Explorer 1 approached this boundary, it detected a shift from solar wind to the interstellar medium, providing critical data about the structure of the heliosphere and its role in shielding Earth from cosmic radiation. The spacecraft's instruments revealed a distinct boundary known as the termination shock, where solar wind slows down and becomes denser. Beyond this lies the Heliosheathas boundary, where the solar wind interacts with the interstellar medium, creating a dynamic and complex environment. Explorer 2's journey has also made a significant contribution to our understanding of the outer solar system. Its flybys of Jupiter, Saturn, Uranus, and Neptune provided crucial data, especially its evaluations of Uranus's magnetic field, which was found to be tilted in a way that challenged existing models of planetary magnetism. These discoveries have sparked further investigations into the magnetic fields of other planets. These missions have not only expanded our scientific understanding but have also piqued the interest of the public in space exploration. The stunning images of distant planets, along with the personal stories behind the spacecraft's missions, have inspired millions worldwide. The breathtaking photographs of Saturn's rings and Jupiter's volcanic moons have become a symbol that inspires the next generation of scientists and explorers. As the Voyager and Explorer missions keep sending back groundbreaking data, the ongoing exploration of interstellar space presents unprecedented opportunities to understand the very fabric of the universe. While the focus has traditionally been on the planets within our solar system, the shift towards studying interstellar space has revealed a few unexpected facts about the regions beyond the Sun's influence. These areas, once thought to be empty voids, have shown complex interactions and phenomena, some of which challenge existing scientific models. One of the most fascinating discoveries made by the Voyager spacecraft is the detection of cosmic rays that originate from outside our solar system. These high-energy particles, which travel through space at nearly the speed of light, offer clues about the processes occurring in distant regions of the galaxy. By studying the energy and composition of these cosmic rays, scientists hope to gain a deeper understanding of the mechanisms operating in faraway stellar nurseries and the dynamics of galactic environments. Moreover, as Voyager 1 and Voyager 2 venture further into interstellar space, their instruments continue to monitor the density and movement of the interstellar medium, the matter that exists between stars in a galaxy. This medium, composed of gas and dust, interacts with the solar wind in a way that affects the shape of the heliosphere, the protective bubble created by the Sun's influence. As the spacecraft pass through and approach this medium, they are providing crucial data that will allow scientists to better model the behavior of matter and energy in the vast distances that separate stars. In addition to exploring the interstellar medium, the Voyager spacecraft have made significant contributions to our understanding of the magnetic fields that exist beyond our solar system. Both Voyager 1 and 2 have provided detailed measurements of magnetic fields in interstellar space, offering insights into the nature of these fields and their role in shaping the surrounding environment. These findings may lead to breakthroughs in our comprehension of the actions of magnetic fields in other galaxies, contributing to a broader understanding of the cosmic forces at play across the universe. The ongoing exploration of the outer regions of the solar system and beyond is not just growing our knowledge of space, but also inspiring future generations of space scientists and engineers. The iconic images taken by the Voyager spacecraft, such as the famous pale blue dot photograph, which shows Earth from a distance of over 6 billion kilometers, serve as a constant reminder of our place in the universe. These images, together with the scientific discoveries made by the spacecraft, have had a profound impact on how we view our planet and our connection to the cosmos. The success of these missions has also paved the way for more ambitious space exploration projects. With the technological advancements made during the Voyager and Explorer missions, the possibility of sending even more sophisticated spacecraft to the outer reaches of space is becoming increasingly feasible. Missions to distant exoplanets, the search for habitable worlds, and the exploration of other star systems are no longer just dreams, but are now achievable objectives for the future of space exploration. Additionally, the data collected by these spacecraft have far-reaching implications for understanding the conditions necessary for life to exist. By investigating the content of distant planets and moons, scientists have gained useful insights into the variables that contribute to habitability, such as the presence of water in the atmosphere and the availability of organic molecules. These findings not only inform our search for life elsewhere in the universe, but also deepen our comprehension of how life might have originated on Earth. The collaboration between scientists, engineers, and institutions around the world in these missions demonstrates the power of global cooperation in the pursuit of knowledge. As the Voyager and Explorer spacecraft continue their journeys into the unknown, they carry with them not only the hopes and dreams of humanity, but also the collective spirit of discovery that drives us to explore the farthest reaches of the cosmos. The anomalies detected by Explorer 1 and other spacecraft also highlight the importance of constant alertness and adaptability in space exploration. As technology advances and new discoveries are made, it is essential to remain flexible in how we interpret data from these distant spaces. Strange signals recently detected by spacecraft could represent new and unexpected phenomena that have never been observed before, pushing the boundaries of our understanding even further. In conclusion, the exploration of space is an ongoing journey that continues to reveal new mysteries and challenges. The discoveries made by the Voyager and Explorer missions have reshaped our understanding of the solar system, interstellar space, and the universe as a whole. As these spacecraft continue their long journeys beyond the reach of human observation, they will undoubtedly continue to provide invaluable data that will shape the future of space exploration for generations to come. The legacy of these missions will endure, inspiring future explorers to venture into the unknown, driven by the same curiosity and desire to understand the cosmos that has propelled humanity's space exploration efforts from the very beginning. As humanity looks toward the future of interstellar exploration, the foundations laid by the Voyager and Explorer missions serve as critical stepping stones. These pioneering spacecraft have not only extended the reach of human instruments farther than ever before, but they have also expanded the philosophical boundaries of how we define our place in the cosmos. The data they have transmitted back to Earth continue to fuel scientific debates, technological advancements, and visionary concepts about humanity's potential to one day traverse the stars. New missions are already being conceptualized with goals far beyond those of their predecessors. Concepts like solar sails, nuclear propulsion systems, and autonomous artificial intelligence-guided probes are gradually moving from science fiction to viable engineering challenges. Projects such as the Interstellar Probe and Breakthrough Starshot aim to build upon the success of Voyager, proposing to send spacecraft that can reach other star systems within a human lifetime. The lessons learned from decades of Voyager's resilience in the harsh environment of deep space will guide the designs of these future missions. Furthermore, the Voyager missions have sparked broader discussions about the role of humanity in the universe. The inclusion of the Golden Records, carrying sounds, images, and messages from Earth, demonstrates a uniquely human desire not only to explore, but also to communicate, to connect with other possible intelligent life forms in the universe. It is a gesture of hope, curiosity, and unity, expressing that we are a species capable of imagining life beyond our own world. As these silent travelers continue to drift farther into the unknown, they embody a kind of immortality. Long after they cease to function, they will remain as artifacts of human civilization, floating among the stars, carrying with them the essence of what it means to be human. In this way, the Voyager and Explorer missions transcend the boundaries of science, entering the realms of art, philosophy, and legacy. The journey is far from over. Each signal received, each anomaly detected, is a reminder that the universe still holds countless secrets. As we continue to develop new technologies, build stronger international collaborations, and foster a global culture that values exploration and discovery, we honor the path forged by Voyager and Explorer. Their voyage is not just a physical one, it is a reflection of our collective journey as a species, always reaching for the stars, always asking what lies beyond.